I'm here to present some of the work I've done on metadata performance improvements, most specifically for file system creation. Kind of defining the problem. The first thing that comes to that somebody eloquently said is that the time we spend creating files is time taken away from compute cycles. So the faster we can get this done, the better for everybody. In my testing, I discovered two distinct problems. One is that OST performance impacts your overall file creation performance, and the second is allowing metadata to go faster. So this is a graph maybe you guys have seen before, maybe not. The vertical axis here is the number of file creates in a second, and the horizontal axis is the number of files in the entire Lustre file system in scales of millions. So as you can see, as up to about 250 million files, you're okay, but then your performance goes. So the first step here is to see if we can flatten that curve out, and the second step is to make it go faster. So I've worked on 3 different changes, and I'll go through each of them kind of briefly. But first, we've tested our changes both in-house, and we'd like to thank the guys at Oak Ridge for running it on their Jaguar XT4 cluster. You can see a definition of exactly what they've got over there. It's a big system, and we're very glad to have a chance to validate that it works not only with, tens or hundreds of systems, but with thousands. The first thing we're going to go through is low watermark detection. Then, actually, this is a little out of order, but directory locking during creates, and finally, the pre-allocation algorithms on OSTs. All of this was developed under 1.8 because that's when I did the work. That's what I had and what was stable. I've looked at the 2.x code, and a lot of it should be, either the concepts or the code directly can be ported directly into there. So first up is low watermark detection. When the metadata server starts creating files, it's got a list of pre-allocated objects on each OST. And as files get created, those pre-allocated objects get used up. After it hits a low watermark, the metadata server starts sending out requests to each of the OSTs saying, hey, give me some more objects. Those instructions are generally ask for chunks inside, 32 objects at a time, partly to reduce the lag between them, and just so you don't wind up asking for 10,000 and waiting 10 seconds to get them. So the current scheme is defined as the allocation size, which is 32, divided by 2. So when you have 16 objects left, it says, hey, it's time for me to start creating more objects. The maximum number of pre-allocated objects you can have is 20,000. So if you're starting to create a whole lot of files really fast, you want at least some cushion. And 16 objects per OST isn't much of a cushion. As you can see, we changed it. The bar on the left here is the Lustre default, and I normalized the graph so that it's 100% of the performance. We changed the watermark to be the low watermark to be whatever your maximum number of your current maximum number of objects is over 2. So if you're maximum number on each OST is 20,000, the metadata server will start requesting more objects at 10,000. So, running a lot of tests, you get a 1.5% increase. And it takes a while to actually get up to that number, but a couple things that are nice about it: it's a one-line change, it's an increase, and it affects, no matter how you're creating files on the file system, you're going to get a bump out of it. The second piece is directory locking. Currently, when a file is created, a lock is taken out on the directory on the MDS. Then the file, all the checks are done, file is created. Then the metadata system goes off and says, well, what OST should I put this on? Gets the pre-allocated objects for the OST, then returns the lock for the inode and the lock for the directory back to the client. The client then sends the message back to the server to say, hey, I don't need the lock on the directory anymore. I made the change in the code to say, as soon as I've created the file in the directory, unlock the directory, because no directory critical operations are happening anymore. Okay, as I was about to say, I'm happy to be corrected on this. And I'm sure there's some details that I'm missing, but in 1.8 I haven't found many. So, yes. Hey, and I'm glad you're here. However, there is an upside to this. Even if there are one or two conditions I'm missing. You get one hell of a performance bonus when you have a whole bunch of clients creating files in a single directory. In this graph, you have the number of threads. Again, you probably can't read this, but the white area here, there's one thread per client. The purple bar is between 0 and 1, or 0 and 2, or sorry, 1 and 2 threads per client, and then the green bar is there's 2 or more threads per client. And the default Lustre performance is down here in blue, and with this change you get this graph here in red. And with a whole lot of, say 8,000 clients creating files in a single directory at once, you get roughly a 340% boost in your file create performance, which I don't think anyone's going to complain about.
What's your scale on the y-axis?
It's IOPS per second. Sorry, I forgot to put that in there. Say that again? I don't remember. I'll go dig that. I'll go dig that up. Okay. So the final piece here is flattening out that curve. And this is one of those things where when I wound up seeing the curve I initially presented, I realized that metadata performance is impacted by your total system performance. So you could have, God's own metadata server, but if you don't have OSTs or OSTs that can keep up, it doesn't matter. The slowest piece of the puzzle is going to be the OSTs and the OSSs. So at a certain point, the OSTs really become a bottleneck. And in this case, this was done on a system with 8 OSTs, but I've done it with any number of them, and you always run into that same peak. Where it is, where this point is moves left, right, depending on the system, but you can still see that once you hit that point, you never actually recover. So, and the reason for this is the algorithm that the OSTs use to create new objects. Each OST has 32 directories on it, and every time it creates a new object, it simply round robins it into the next directory, which is fine for a while, except if you have, we're still working on an ext file system, and if you start getting like 1 million files in a directory, your performance is going to start to suck. Because you've got to, you have to search through all of that, you've got to flush out the cache, you've got to do any number of things, and that's just for one file. When you go and create the next file in the OST, you got to do all that all over again. So what I've done is, first of all, bump up the number of directories in an OST from 32 to 4096. And when I did that, I saw the blue curve here shift to the right. But the problem didn't go away. The next thing I did was say, all right, the first 65,000 files I create all go into directory 0. The next 65,000 go into directory 1, and on and on and on again. So you get very good locality on an OST when you start creating lots and lots and lots of files for hours and hours and hours and hours. And so these tests, the blue one is the one is the original Lustre graph, and the red one is the change I made. And so it just, at this point, I stopped the test because you kind of get the point, but both of these tests ran for the same amount of time, and you got, at least at this point, 50% more files. And the longer the test runs, first of all, the worse the blue graph is going to get, down to about 2,000 file, 1 or 2,000 file creates a second. But second, the red curve stays completely flat until you run out of inodes on the metadata server. At which point, bad things start happening. So a couple of good things is, yes, you have more OST directories, but they're all small. So when you start doing regular opens, not just creates, you're opening directory 3, and there's very few things actually in there. So you get a response from that directory much more quickly. During creates, you have good locality. You're not constantly thrashing among the 32 directories, and your inode cache isn't going as nuts. And finally, your performance is consistent, regardless, pretty much regardless of the number of OSTs you have. So the conclusion is that we've got some significant performance, and obviously we need some code review on one of them from 2 distinct areas, and we're going to release the code to everybody to take a look, see what we've done, and comment on it, tell me where I'm wrong, et cetera, et cetera. So I guess that's about it. Anybody have any questions? What a surprise.
So let's start with the OST allocation changes.
Yes.
So, have you studied any impact on actual performance of reading and writing those files that you are creating in 64K chunks? Because actually, I would expect there would be some sort of a slowdown, because now your related files from the same job all end up in the same directory. So for each IO, every time we do a lookup, all threads will actually contend for the same parent log for a directory. There was a very good reason why those entries were actually spread around of this many directories.
Actually, I actually hadn't tried that, but I could probably go ahead and do that. I'd imagine that once the files themselves get opened, that that the actual throughput would remain the same, but there may be a delay in opening all 65,000 files.
Actually, there is no opening on the OST side. It's each object is looked up separately every time an RPC arrives.
Okay.
Another interesting thing I saw on your graphs is, did you actually see any performance increase from the increase in the number of pre-allocations? We just have figured out there is a bug in 1.8 and 2.1 releases, all of them, that sort of pegs the pre-allocation count at 32. It's Jira issue LU 170 for those interested. And when we actually fixed it at Oak Ridge system and tried to see what of effect does it have, it doesn't have any effect on big systems, because there are so many OSTs that if you are out of objects on one OST, we no longer allocate objects there while waiting for pre-create to come through. And we still have plenty of other OSTs where we can draw our objects from.
Okay, say that one again. There's about 4 questions in there.
So I see you have 1.5% increase when you do something with the pre-allocate rates, but you still somehow are sure that there is a positive impact in some cases. But on the systems, the large ones, just like at Oak Ridge, there are so many OSTs that even if you create only 32 objects at a time, when you are out of objects for one of the OSTs, you still have plenty of other OSTs where you can create objects. And we are actually very smart about it, and we don't try to synchronously wait for a specific OST to become available, to have available objects.
Yes, that change was the system that was tested on. I think there were 24 OSTs in the system. So it is one of those things where on a system as large as Oak Ridge, you probably won't see the effect, but on a smaller one, you will.
Sorry to barge in here.
That's okay.
This conversation really should have been taking place on Lustre Discuss. So I think your results are great. I'm really pleased to see work like this going on. But it would be a benefit to all of us, I think, if we were talking about this as it happened rather than waiting for an announcement.
Yes. But that decision was made by the people who signed my paycheck, not me.
I'm really appalled that you didn't talk to us sooner about that locking of the parent directory that you mentioned, because it's so very wrong, and I will explain to you later why. But the proper OneCloud recommended way to do this is to migrate to 2.1, where this is all done properly. So that all you know, that there is the 2.1 and actually even 2.0 already contains the code that does the smart sync with the directory lock. So.
Thanks.
No, I'm not going to talk about the Zytex way to do it, but although I am going to point out that it's an interesting problem. This actually illustrates a very interesting problem because the designer, the implementation choices clearly weren't documented in the code, and there's no master document to go to as to why that rationale was implemented in the first place. So it kind of illustrates that a lot of the knowledge is in people's heads and not actually documented in code and not actually documented in any kind of developer guide, and highlights that if we're actually going to grow the pool of talent in the community, that there are some key critical pieces that need to happen, including, quite frankly, much better documentation in the code and design stuff going forward by any of the developers who are working on Lustre in the future, so that we're no longer constrained in the, going forward by a small closed talent pool that has historical knowledge. Okay, good. Well, that's encouraging to hear. And if it's all kind of in the same, if it's all in one place that developers can find, then that'll make their jobs a lot easier. I think it also illustrates the importance of communicating design decisions or having design discussions very early in the process so that we avoid kind of costly mistakes.
What I'm hearing is we need to have an architecture call, and we have multiple community forums for doing this, but I think we need to have some of the principal engineers that have this knowledge, that are working in this area, work together, weekly calls with the community to discuss what are the architectural issues, what's the path forward, and let's move, and let's get everybody aligned, because it's a small community. I think the work's great, and I applaud it. But I do agree that we all need to work together on this.
I'm sorry. I mean, is Lustre Discuss the vehicle for doing this, or is Lustre Devel? Because
Devel, probably,
I mean, our experience with Lustre Discuss is the more information you put into a question, the less likely you are to get an answer. So if that level of detail went into Lustre Discuss, you were certainly not going to get anything back.
Chris, you had a question. Do you still have a question?
I was just going to reiterate a point. The bosses of all these companies need to allow the developers who all want to work together to work together. If you're keeping your guys from releasing their stuff in the public, that's just not going to work. We all need to work together.
Well, right on. All right. Thanks, Ben.
Thanks.